The first thing, we have to write down our recurring decimal. So it's 19.45 and the 5 is recurring, right? So you say let x be equal to 19.45. Okay, I'm sure you can see that here we have got 2 decimal places, right? But the 5 repeats itself up to positive infinity. So to make things easier for myself here, since I have got 2 digits after the comma in the original question, it means when I say let x be equal to, x must also have 2 the decimal place, or rather it must have 2 digits after the comma. Then, since we have a 5 which is recurring, we put dot dot. That's our first equation. Okay? Then, since we have got 2 digits after the comma, which multiple of 10 has got 2 zeros? 100. So we multiply by 100. So by multiplying equation 1 by 100, okay, so if you multiply equation 1 by 100, you get 100x equal to, now I want you to pay attention carefully what I'm about to do now. If I multiply 19.45 recurring by 100, I'll end up getting 1945, right? But then there are 2 5s that are after this 5. Those 2 5s after this one, they are invisible in equation 1, which means you can't see them with your eyes. But they are there because the whole number, okay, it has got a 5 which is recurring. Therefore, after the comma, I'm going to end up having a 5, 5. Then I can put my dot dot because there are still other 5s after this third 5, right? So this becomes my equation 2. Are you following that? Then subtracting equation, we are subtracting equation 1 from equation 2. If we subtract equation 1 from equation 2, we will get 100x minus x is equal to 1945, minus 19.45. Okay, now let's do the subtraction. So on the left you get 99x, on the right you get what? You get 19. 19? You can't do 19. 19 what? 26, comma what? Comma 10. Okay? Are you following? So if I add 1926.10 to 19.45, I'll get 1945.55. You just have to use your calculator, it's not complicated. Or you can do it mentally. Right? Now, when you get here, I'm sure you can see that on the left hand side, we don't have a decimal. We have got a coefficient of x, which is a positive integer. But on the right hand side, we've got a decimal. We need to convert now that number on the right hand side to a common fraction. Okay? Because remember, we don't want decimals here. The question says, show that the following recurring decimals are rational. Rational numbers are also called fractions. So here we need to write those recurring decimals as common fractions. That is in the form a over b, where a is an integer, b is also an integer. Are you following? Right, so next page now, we convert that. So we can have 99x is equal to, now I hope you are aware that 0.10 is the same as 1 over 10. Okay? I hope that you did this in the lower grade. If I ask you to convert 0.10 to a common fraction, what's the answer? 1 over 10. Okay? So I'm going to convert this 1926.10 to a mixed number first. Then I'll convert the mixed number to an improper fraction. Okay? So it will become 1926 and 1 over 10, which is the same as 99x. If I multiply that, I'll get 19,261. Okay? By adding that one there over what? Over 10. Are you following that? I've converted 1926 and 1 over 10 to an improper fraction. So 10 times 1926, that will give me 19,260 plus the numerator, which is 1. You get 19,261. Okay? Then I want to solve for x. So my denominator there is a 1. Then you cross multiply. So you get 990x is equal to 19,261. If I divide this, I'll get x is equal to 19,261 over 990. Okay? We have a common factor there. Can you try to use a calculator if this can be simplified? If you don't get an answer which is a common fraction, then it means it can be simplified. I hope you know how to convert a decimal to a common fraction using your calculator. Yes? 1751. So it becomes x equal to 1751 over 90, which means there's a common factor. Okay? Are you following? Now, let's test our answer now. Let's test our answer if it's correct. Whenever you're converting a recurring decimal to a common fraction, you can verify if your answer is right or wrong. So I want you to put this in your calculator, convert it to a decimal on your calculator. 1,751 divided by 90. Convert it to a decimal. What answer are you getting?
19.454.
Yes. So you're getting 19.45 for the carry, which is the same number we had at the beginning, which is this one. Are you following? Right. So that's what you're expected to do. Right, let's do another question. So I've done that one. Now, let me do number 6, whereby we've got this one now, we have got a digit. Okay? We have got a digit, which is a 1, which is recurring, a 2, which is not, a 4, which is recurring. Right? So 0.1 recurring, 2 and 4 recurring. Right? So let me move on to the next example. So that's number 6. So D6.